2 and 1, welcome back. Trigonometry, cosine law. So we have here an acute triangle, and the cosine law is basically utilized if one of the angles is given and then the adjacent two sides, so the length of the two adjacent sides are given. And if that is given, then you can find always the opposite side. So for example, so here we can make the assumption that this angle C is given to us. And we have now the opposite sides. So I'm going to write, so Lillo A, so this means the length of the opposite side of that angle A at that vertex. Then I'll make this B, which is going to be the opposite side of the B vertex, or that B angle. And then I'll make this little C, and that is the side that we're trying to find. So if you're trying to find this side and these two pieces of information are given in terms of the sides, and you know this angle, then you can use this, which is known as the cosine law, to find it for any acute triangle that you have. Now, why is this actually true? So that always interests me. It may not necessarily interest you. So if you just want to use, and you're watching this to refresh yourself on what this cosine law is, you can stop the video here, maybe fast forward to the example, and off you go. But I do want to show you, for those interested, where does this actually come from? So I'm going to try to derive it so that you don't think it's just magic. Let's do it. All right, so the first thing that I'll do is something that I did with the sine law. I'll put a link up above to the sine law if you wanted to see that derivation. But what I did there was I just dropped, okay, so really just kind of a perpendicular line, which would serve as kind of the height. So I'll call this H for the height of this triangle. I'll put, just for convenience, so here, let me move this A out of the way for just a little bit. So I'll put D, so this will be kind of like the next point. So this is that point there. And if I do this, so what I'm going to try to do now is I'm going to try to dissect this, and I'm going to try to write this C. So my goal to write this C is in this particular way. We know that we can use the Pythagorean Theorem to be able to solve, okay, so for this C, if we knew what this H was, and then if we knew, okay, what this distance between D and B is. So if I know these two distances, this one and this one, then I can find my C. So that's what I'm going to actually do. So I'm going to write this thing just as a reminder here for us. So we will try to do this. We're going to have C squared is equal to, it's going to be equal to H squared, so that's the height squared, plus the distance, which is D, B squared. So that is that distance there at the bottom. So if I knew those distances, I could get C squared. So now what I'm going to do is I'm going to rewrite H, and I'm going to rewrite this dB in terms of the information that is given. And this is going to lead us into basically the cosine law. All right, so that's what you see there. And it's called cosine law because you have a cos of the angle right there. All right. Okay, so let's try it. So I'm going to first, okay, so try to rewrite this, these H's and then the dB, okay, first for us. So let me clean this up. Okay, so let's begin. I'll switch the color here so it stands out. Okay, so what do I know? I know that, for instance, okay, so from this angle, so I know that I have, so sine of that angle C is basically equal to the opposite, so that is H, okay, so that's the height, divided by the B, which would be the hypotenuse of this particular triangle right here. So I know that that is true, which means, so from here, I know that H is simply nothing else but B multiplied by sine of that angle C. Next, what I'm going to do is I'm going to write, again, this angle, except I'm going to write it with the cos. So cos of that angle is defined by simply the adjacent. So now my adjacent is right here. So this is the adjacent side right there. And you'll see why we need that shortly. So that adjacent side I'm going to designate as CD, divided by, again, the hypotenuse, which in this case is just B. And just as I had above, so this tells me that this distance CD is equal to B in terms of the angle C. All right. Now I'm going to move over and I'm going to take this particular Pythagorean theorem and try to substitute everything that I know. Now, I know what H is. So H, what I have H right here. So that is my H. Now, I do not know what dB is. However, I can rewrite dB, and I'm going to do that for myself. So dB is simply equal to, so that's this distance right there. So that's from here to here. That's that distance. That distance is equal to the entire A. So let's not forget, so this whole piece, so this whole entire piece of that triangle is A. And it is A minus this distance, right? So it is this distance right here, which was just CD. But I do know what CD is. CD is just B multiplied by the cos of the angle C. So now I have H right here, and I have dB right here, which I can substitute inside. And you'll see that once I substitute, we're going to get into our cosine law. So let's do that substitution. So that substitution is going to give me, it's going to give me C squared is equal to, now H squared, so that's going to be B multiplied by sine of the angle C, so this is all squared, plus, now dB, so I'm going to substitute dB in here, which is A minus B cos of the angle C. This is all squared, so that's that. Now, squaring these, so that means bringing this and squaring, so I'm going to get B squared, and I'm going to get sine of C squared, which we write as sine squared C, so that's exactly the same thing. Plus, now I have to square this entire thing, be A squared right here, minus, now as I'm squaring it because it's a perfect square, so this is going to turn out to be 2AB cos of the angle C, and finally plus, at the end there, B squared cos squared C. And you can do that, you can take this entire thing and square it, if you like, for yourself, and you're going to come out to this. I'm going to now simplify this. So notice, here is my A squared. So I'm going to write A squared, okay, so that's that. Now, these two terms, so this term right here, and this term right here, they have a B squared in common. So I'm going to factor out the B squared. I'm going to factor this out, and that's going to leave just sine squared of the angle C plus cosine squared of the angle C. So that's what I have there. And finally, so that is minus the last term, so this one, which is 2AB cos of the angle C. Now this right here, this bracket is equal to 1. This is equal to 1. If you want, or if you don't remember why this equals to 1, I'll put up a link up above where I show that for yourself. It's about a 5-minute video if you like. Now, if this is equal to 1, then notice what happens. You have A squared plus B squared minus 2 AB cos of the angle C, which is your cosine law. And that's where the cosine law comes from. Now, this cosine law is for any angle that you like. So it's not just the angle C. We arbitrarily just kind of labeled this triangle ABC, and we said we were looking for C where the C angle was given. But if any other angle is given and any adjacent sides, then the cosine law is the same. So you can write this in any way you like. So for instance, if they gave us the A angle, we could have written as A squared is equal to B squared plus C squared minus 2BC cos of the angle A. So what happens is, so notice this is your BC, that's the opposite sides. Those are going to be exactly in here. And then this is the angle of what you are looking for. So you can write the cosine law for any angle that you wish. Let's try to apply it to one example. So here is an example. And so here what we have is we have an angle, and then we have two of the sides that are given. Now these have to be the adjacent sides. If they're not the adjacent sides, then the cosine law is kind of useless. It won't help us. But if the adjacent sides are given, and then the interior angle is given, then we can actually use the cosine law to find out what this length is equal to. So in here, so what I have, so if, let's say if this was the angle C, then this would have been C squared is equal to, again, A squared, say if this was A, plus B squared, this is my B, minus 2 times A times B times cos of the angle C, which is given. And now if you substitute all of this in, so let's say it was 13 squared plus 15 squared minus 2, A, which is 13, B, which is 15, cos of 85. And now you can compute it. The only thing is, I'll say from my experience, I always forgot that, this is actually squared. So once you find what this equals to, then don't forget to still square it. So we have to still take the square root, okay, in order to find the actual C. So let's plug all of this in here. So I'm going to do that. So I have, so this is 13, which is squared. All right, plus, so this is going to be plus 15 squared. Okay, I'm going to hit equals. So those are those two. So we're going to take our answer minus, and now we're going to subtract. So this is going to be 2 times 13 times 15 times, and this was cos of the angle 85. So that's what we have there, equals, and that is 360, approximately, so let's say 360. So now in order to find my C, so I'll take the square root of 360, or whatever that answer is, if you want it really, really precise, and that would have been our answer. So what does that tell us? I mean, it's approximately, I guess, 18.97, or approximately, give or take 19. And that is the length of that C. That's how you can use the cosine law. And that's where it comes from. All right, thanks for watching. We'll see you in a future video. Okay, bye everybody.